This is mathheals.com. You can go here to get more, find more links to math videos on YouTube, if you wish. Let's take a look at the parabola. And here it is. Now we're going to have two forms of this. We have one where we have x minus h squared equals 4p times y minus k. If we got that, then our formulas for the vertex are hk, focus is h, k plus p, and directrix is y is equal to k minus p. Now if you have it in our second form, the y minus k squared equals 4p times x minus h, then your vertex would be hk again, focus is h plus p comma k, and directrix is x equals h minus p. Now how to tell which formula to use. The top one, the square root is on the x. The bottom one, the square root is on the y. That's your main distinction between them when you're working problems. So let's look at our first problem. We're going to talk more about what the focus and directrix is after we find it. It's best shown with a picture. Okay, we got y squared is equal to negative 2x. Well, if I come over here, the square root is on the y. So square root is on the y is the bottom formula. So we're going to try to get it to look like this. So we want y minus something squared. So we want to rewrite the y squared by putting a number in here so we don't change its original value. Well, that'd be 0. Because y minus 0 is y, and y to the second power is y squared. Now over on the right side, we need parentheses. So easiest way to get parentheses in front of the x, because that's what we have here, parentheses in front of the x, is to factor out whatever number's in front of the x. So factor out a negative 2. Well, then I want to rewrite this as x minus something. Well, again, we can rewrite it as x minus 0, same little trick we did on the y's. And I want to rewrite this as 4 times something. So that's what my formula says, 4 times p. Well, this would be negative 2/4. Very easy. Whatever number is right here always goes up on top, and then you always put a 4 down in the denominator. And that'll always work. You don't have to think very hard about what it should be. Now from our formula, k is what goes with our y. And it's going to be opposite sign. Of course, 0 doesn't have a sign, so k is 0. And from our formula, this is our h. And it's also going to be opposite sign. But again, h or 0 doesn't have a sign, so it's just that. And this is our p, because it's 4 times p. So p is equal to negative 1/2. Now they're not asking for all the pieces of information. They just say find the focus and directrix. But let's go ahead and find all of it. Helps with the graph. Our vertex, it says, is hk. So our vertex is hk, and we said h was 0 and k was 0. Now our next one is focus. Focus is h plus p comma k. So h plus p comma k. H we said was 0, p is negative 1/2, and k is 0. So this would be negative 1/2, 0. Our directrix. Directrix is x equals h minus p. Well, h was 0 minus p is negative 1/2. So that's a negative negative, so we get x is equal to positive 1/2. Okay, let's draw the graph now that we've found those pieces of information. Vertex we said was 0, 0. Focus was negative 1/2, 0. So negative 1/2, 0. This is our vertex. Negative 1/2, 0 is right here. Our directrix is x is equal to 1/2. So we're going to have a line here, a vertical line at 1/2. And that's our directrix. Okay, to come up with our graph, See where my point is right there? Now eyeball the distance between that and the focus and that and the directrix. And you want to move it. See, like if I was down here, the distance from here to the focus is longer than the distance to the directrix. So you want to keep moving it until they're the same. Say right there. So again, I'm eyeballing this distance. Let's say that distance is, I don't know, 1.2. Then if I go over to my directrix, forming a sharp corner, 90 degrees, that distance should also be 1.2. Now if I come over here, I put my point right here, I'm eyeballing the distance between the focus and the directrix. That's not bad right there. If I look at the distance from here to the focus, let's say that distance is 3. If I go straight down to the directrix, forming a 90 degrees, that distance should also be 3. And so you just kind of eyeball it, and it doesn't matter where you put those points at, in case you're wondering. Like that. And then there's symmetry. So once we get one piece of it there, we can use symmetry to draw our other piece like that. So the graph it matches would be C. So that's the, and I'll graph another one to show the directrix and focus. But again, that's what the definition of those are. They're used to help you come up with the graph. Okay, number 2. We got x squared equals negative 8y. And it says find the focus and directrix. Okay. Squared is on the x. Squared is on the x is the top formula. So I'm going to try to get it look like this. I want x minus some number. Well, we saw this trick in the last problem. You can rewrite that as x minus 0. Because x minus 0 is x, x's second power is x squared. Now, we need a parentheses before the y. Well, we can always factor out the number that's in front of your y. Okay. Then we want to rewrite what's out in front as 4 times something, and the y we want is y minus the number. So do y minus 0. Now again, if you're not quite sure what this should be, I mean this one's pretty obvious. 4 times negative 2 gives you negative 8. But if you don't know, whatever number you have up here, put up on top, and you always put 4 down there. Now from our formula, this is h, and it's going to be opposite sign, but 0 doesn't have a sign, so h is 0. This is k, it's going to be opposite sign, but k doesn't have a sign, so k is 0. And this is our p, so p is equal to negative 8 over 4, or p is equal to negative 2. Now it's asking us for the focus and directrix. We're using the top formula here. So focus is h, comma, k plus p. Well, h we said was 0. K is 0 plus p, which was negative 2. So our focus will be 0, negative 2. Now our directrix will be y is equal to k minus p. So y is equal to k minus p. K we said was 0 somewhere. Minus p, so minus, and p is negative 2, so we minus minus. So we got y is equal to positive 2. And those will be your answers. Number 3, we have 4y squared plus 2x equals 0. It says find the focus and directrix. Okay, well let's go look at our forms. Obviously we want the squared on the y, so we want the bottom formula. I want that as y minus something. We can't have any number in front of the y. Well, we also can't have the x over there, so I guess the first step is take the negative, or 2x over the right side becomes a negative 2x. Now I don't want the number in front of the y, so I'm going to divide everything by 4. Like that. And those 4's would cancel and gives us y squared, and that gives us negative 1/2 x. Okay. Now remember, what we want is we want y minus a number. So we'll rewrite that as y minus squared. We want a parentheses before the x, so we always factor out the number that's in front of our x. So I'll factor out a negative half. Now I'm going to rewrite that as 4 times something, and then this should be x minus a number. And again, we put 0 there. Okay. What should this be? Have no clue. But if we take the number here, we put it up on top, and we put 4 down here, then that'll help us figure out what it should be. Well, from our formula, this is our k, and it's opposite sign, so that's 0. This is h, and it's opposite sign. Again, I know zeros don't have a sign, but and then this will be our p. So we got p is equal to negative 1/2 divided by 4. That's what that says, negative 1/2 divided by 4. Well, we never divide fractions unless they're both fractions. So I can rewrite the 4 as 4 over 1. And we never actually divide fractions. We immediately rewrite as multiplication by taking a reciprocal, flipping the second fraction. So 4 over 1 becomes 1/4, which then gives us negative 1/8. And that's our p. Okay. So from our formula, focus is h plus p comma k. H plus p comma k. H was 0, p is negative 1/8, and k is 0. So this would be negative 1/8, 0. Now our directrix is x equals h minus p. Well, h is 0 minus, what was p? P is negative 1/8. Negative, negative gives us positive, so we got x is equal to 1/8. And that's all they're wanting there. Let's take a look at our next problem. They tell us the focus is 6, 0, and directrix is x equals negative 6. And they want us to find a standard form of the equation of the parabola given those conditions. Directrix, x equals negative 6. We have directrix up here, y equals something, and down here we have directrix x equals something. It matches this bottom one, so this is the formula we're going to be using. Now x equals h minus p. Well, that tells me that this right here is equal to h minus p. Now our focus, the first part is h plus p. So this right here tells us that h plus p is equal to 6. And then the second part is k, so this is k. Now to find our standard form, we have to find h, p, and k. Well, we got k. Let's find h and p. I got h plus p is equal to 6. And I got h minus p is equal to negative 6. Well, I can add these equations together. This is elimination method, addition method. H plus h is 2h. P minus p drops away. 6 minus 6 is 0. So then I got 2h equals 0. Divide both sides by 2. And we get h is equal to 0. So if h is equal to 0 and h plus p is equal to 6, we can now plug 0 in for the h. So we got 0 plus p is equal to 6, which implies p is equal to 6. Okay, so we got our h, we got our k, and we got our p. We said it was the bottom formula. So we got y minus k squared is equal to 4 times p times x minus h. This is right here. So let's plug in what we got. K we said was 0, so we got y minus 0 squared equals 4 times p, which is 6, times x minus 0. Y minus 0 is y, so we got y squared equals 4 times 6 is 24, and we got an x, and that x minus 0 drops away. So our answer would be y squared equals 24x. Let's look at another one of those. Tells us focus is 0, 12, and directrix is y is equal to negative 12. Okay, directrix is y equals. Let's go look. Directrix is y equals, directrix is x equals. So it's our top formula. So directrix is y is equal to k minus p. So they're saying this negative 12 is equal to k minus p. Now our focus. The first part is h. So they're saying this is h. And they're saying our second part is k plus p. So k plus p is equal to 12. Well, remember, to put it into our standard form, which is what they're asking, find a standard form, we have to find h, k, and p. We know h, so let's find k and p. Well, we got k plus p is equal to 12, and we have k minus p is equal to negative 12. So we'll use the addition elimination method again. K plus k is 2k, p minus p drops away. 12 minus 12 is 0. Divide both sides by 2, and we get k is equal to 0. Now k plus p is equal to 12, so if we just found k is 0, we'll put 0 in there. We've got 0 plus p is equal to 12, or p is equal to 12. Okay, so we know h, we know k, and we now know p. And we said it was the, which one did we say? Top formula? Top formula. So we want x minus h squared is equal to 4p times y minus k. Well, h we said was 0, so let's plug that in. X minus 0 squared. P is 12, so we'll plug that in. And k is 0, so plug that in. Well, x minus 0 is x, so that's x squared. 4 times 12 is 48, and y minus 0 is y. So our answer is x squared equals 48y. Let's look at another one of those. So we've got our vertex is 4, negative 3. And our got a focus is 7, negative 3. Let's go look at our formulas. Well, both of them got vertex and focus, so that doesn't help us very much. Now, notice something, though. The negative 3's are the same here, aren't they? So the y parts are the same. Let's look at these. Y parts are the same. Here I got k, k plus p. Those aren't the same. Here I got k and k. So in this bottom formula, my y parts are the same. So we're going to be using these down here. Now, no matter what, this is your h, and this is your k. So h is 4, and k is negative 3. And we said we're going to use the bottom formula here. So along with our focus, we said the first part is h plus p. So this part is h plus p, which over here we just said h was 4. So we got 4 plus p is equal to 7. P is equal to 7 minus 4, or p is equal to 3. And we said we're using the bottom formula. So we got y minus k squared equals 4p times x minus h. Well, we got y minus, and k was negative 3. 4 times p, p is 3. And x minus h, and we said h was 4. Do a little bit of simplifying. Minus minus becomes plus. So we got y plus 3 squared. 4 times 3 is 12, and then x minus 4. And that's our standard form, which I think they're asking for. Yeah. One more of those. Okay, number 7. focus is 5, -2. And our directrix is y is equal to -7. Find the standard form again. Okay. Directrix is y equals a number. Directrix is y equals. Directrix is x equals. So it's our top formula, because the directrix is y equals up here. So directrix is y is equal to k minus p. So they're telling us that k minus p is equal to -7. Now we're using top formula, so for our focus, first part, the x part is our h. So this is h. And our y part is k plus p. So this is k plus p. Well, we need h, k, and p. So we got h. Let's find k and p. So I got k plus p is equal to -2, and k minus p is equal to -7. Merging these together. We use elimination addition. K plus k is 2k. P minus p drops away. -2, -7 is -9. So k, when we divide both sides by 2, is going to equal to -9/2. That seems weird. Let me double check that. Y equals, okay, h, k plus p is equal to -2. K minus p is equal to -7. Put those together, 2k. Well, sure enough. So now we have h and k. We need p. Well, if k plus p is equal to -2, we just found k. We put -9/2 in for k. Plus p equals -2. Take the -9/2 to the right side and becomes a positive 9/2. -2 plus 9/2 gives us 5/2. What I did there is -2 times 2 gives us -4, plus 9 gives us 5. Okay, so now we know h. Which formula was it? Top one. So x minus h squared equals 4p y minus k. So we now know h, k, and p, so we'll plug them in. H is 5. 4 times p, and p is 5/2. And y minus k, so y minus, and then we put in -9/2. So we got x minus 5 squared equals 4 times 5 is 20, divided by 2 is 10, times y plus 9/2. And that's our answer. Okay, this one says find the vertex, focus, and directrix, then graph it and match it to the graph. So we got x plus 2 squared equals 8 times y plus 2. Squared is on the x. So when we look at our formulas, squared is on the x, we use the top formula. Now it's just about in the right form. We want x plus or x minus a number. So that's good. But we want to rewrite this as 4 times something. And that should be y plus or minus a number. So that's good. Well, again, if I don't see it, take whatever number you got there, put it over 4. Now this is going to be our h, and it's going to be opposite sign, so it'll be -2. This is our k, it's going to be opposite sign, so it'll be -2. And this is our p, and it's same sign, so it'll just be 8 over 4, or 2. Now our vertex is hk, which was -2, -2. We're dealing with the top formula, so our focus is h, k plus p. So h, k plus p. Yeah. Well, h we said was -2. K is -2 plus p, which was 2. So this gives us -2, 0. And our directrix is y is equal to k minus p. K we said was -2 minus was p. P is 2. So we got y is equal to -4. Okay, let's graph this. Our vertex is -2, -2, which is right there. Our focus is -2, 0, which is right here. And our directrix is y is equal to -4. Which looks like that right there. So that's our directrix. Again, I'm putting a point anywhere here. Like I put it right here. Now look at the distance between my point and the focus and directrix. It's a lot longer to go to the focus. So I'm going to move this up until it looks about the same. Look at right here. The distance from this to the focus and this to the directrix looks about the same, doesn't it? So again, let's say that distance there is 5, then going straight down to here, forming a 90 degrees, should also be 5. Now I'm not very good at eyeballing these, so you may be saying, well, that's not good enough. It's probably true. Okay, right there. Again, if that distance there was 7, the distance from there to my directrix would be 7. So you can put them anywhere. You're just trying to eyeball it. The distance right there. That distance from there to the focus looks like that same distance to directrix. Now once you get enough points, whatever that might be, you draw it, and this is symmetric around this line, so we would draw it over on this side like that, which would match B. Let's look at our next problem. Number 9. We have y plus 2 squared equals -12 times x minus 3. The squared is on the y. So if I come over here, squared is on the y is the bottom formula. And it's almost perfect. That's okay as is. We need to rewrite this as 4 times something, and this is x plus or minus something. Well, that's good. -12, well, that's 4 times -3. So this is going to be our k, and it's going to be opposite sign, so that's -2. This is our h, and it's opposite sign, so it'll be 3. And this is our p, and it's the same sign, so p is -3. Okay, our vertex is hk, which is 3, -2. Our focus, I have no clue. It's one that's squared on the y. Squared on the y is the bottom one. So focus is h plus pk. So h is 3, p is -3, k is -2, so I got 0, -2. And our directrix is x equals h minus p. So we got h, what am I doing? H is 3 minus p, which is -3. So we got x is equal to 6. Negative, negative becomes positive. Okay. 3, -2. That's our vertex. Focus is 0, -2. So 0, -2, right here. And our directrix is x equals 6. I got something wrong here. Let me check. K is -2, h is 3, p is -3. Vertex is 3, -2, hk. H was 3, k is -2. Squared is on the y. H plus pk, h plus pk. So h is 3 plus p, which is -3, that's 0. K is -2. And x equals h minus p. So we got h, which is 3, minus p, which is -3. We got x equals 6. And I think I'd better go back to pre-algebra. Let's try that again. Vertex is 3, -2. I have to quit drinking so much before I create these. And then x equals 6. Okay, that looks much better. I said I'm off the booze as of today. Actually, I don't drink at all. Can't blame it on that. It's the fluoride in my water. It's making me insane. The reason I knew it was wrong is your vertex has to be exactly in between your focus and your directrix. Like if this distance is 3, this distance has to be 3. So you couldn't have it the way I had it. Okay, now I'm going to pick a point. Drop it here. I'm eyeballing the distance between the focus and the directrix. And that looks about the same. That distance of directrix there is probably about the same as that. Come over here. I'm going to... Yeah, that's about right. Distance to the directrix is about the same as distance to focus. And then draw my graph. And then by symmetry, it's... You can't see it, but... Okay. That's so bad, I'm going to do it over. Try it again. Okay. Doesn't have to be perfect, but it shouldn't be that far off. And those would be your answers. Okay, let's look at our next one. We've got y squared minus 4y minus 12x plus 64 equals 0. And it tells you what to do. It says convert each equation to standard form by completing the square on x. So we're going to write this in standard form. Our first step is to get everything with... See how we have the squared on the y? So we want to get everything with y on one side and everything else on the other side. So get everything with a y on one side. The variable is squared. Now in a different problem, it could be the other variable. So get everything with a y on one side, everything else on the other side. So I got y squared minus 4y, and I'll take negative 12x and 64 to the right side. And the signs of them change. Take anything across your equals, your sign changes. I write that down right? Negative 12x, yeah I did. Huh, maybe it comes out nice. We want to complete the square on the y's. Now to complete the square on the y's, we take the number that's before our y, which is negative 4. We always multiply it by half, and we always square it. That's completing the square. So always multiply it times half, and always square it. Negative 4 times a half gives us negative 2, and negative 2 squared gives us 4. And then remember, it's completing the square, we add that to both sides. Like that. Now, along with completing the squares, we then factor this. This becomes y minus 2 squared. And over here, negative 64 plus 4 gives us negative 60. Now, remember the little trick for this. Whatever number is right here, right before you square it, sign included, is always what goes right here. So there's really no factoring on that. Now that part looks good. If I come over here, y minus 2 squared, that looks like this. We just need to rewrite this right side a little bit. We need a parentheses before the x, so we'll factor out the number before the x. So factor out the number before the x. So we got y minus 2 squared equals 12 times x minus 5. It's even closer. So I got y minus 2 squared, and remember we want to rewrite the number out in front as 4 times something. Well, that'd be 4 times 3 would give us 12. This is our k, and it's opposite sign, so k would equal 2. This is our h and its opposite sign, so h is 5. And this is our p and its same sign, so p is 3. Now our vertex is always hk, it doesn't matter which form it is. So we got 5, 2. Now the square root is on the y. Square root is on the y is the bottom formula. So our focus is h plus pk. So focus is h plus p, k. Well, h is 5 plus p, which is 3, comma k, which is 2. So this will give us 8, 2. Our directrix is x equals h minus p. H is 5 minus p, which is 3. So we get x equals 2. And to graph this. So I could actually plot a point this time. 5, 2 would be right there. Focus is 8, 2. 6, 7, 8. Focus. Directrix is x equals 2. And I notice that the vertex is halfway in between the directrix and the focus. So that's good. It's kind of a check you can do. Now I'm going to eyeball it here. I'm looking for a distance between the focus and directrix. That it looks like a good point. That's probably not perfect there, but good enough. So again, we're eyeballing the distance from the focus to the directrix. They should be the same. And you can put the point anywhere. So then I draw my graph. And by symmetry, this is going to look like that. Last problem. And then actually I'm done with college algebra. I was re-recording these in YouTube format, so party time. Except for I don't drink. And I really don't party, so I guess I'll pull out my math books and study some equations. Okay. Now here the square root is on the x's, so I'm going to get the x's on one side and everything else on the other side. So I got x squared minus 12x equals, I take those to the right side, it becomes 12y minus 60. Okay, and we want to complete the square on the x's. So we take the number before x, which is negative 12, times a half and squared. That gives us negative 6 squared, or 36. And then we add that to both sides. Now this side factors over here as x minus 6 squared. Again, remember the little trick for that. Whatever number's right here, sign included, right before you square it, is always what goes right here. Negative 60 plus 36, what is that, 24? Yeah, minus 24. Now this one's good here. We need to have a parentheses before the y, so we always factor out the number that's before our y, which is 12. And we want to rewrite this as 4 times something. So 12 becomes 4 times 3. This is our h, and it's going to be opposite sign, so it'll be positive 6. This is our k, and its opposite sign, so it'll be 2. And this is our p, and its same sign, so it'll be 3. Our vertex, no matter which form, is always hk. So this is 6, 2. Our focus. The square root is on the x, so if I come over here, square root is on the x is the top one. Focus is h, k plus p. H we said was 6, k is 2, plus p, which is 3. So we got 6, 5. And our directrix is y is equal to k minus p. K we said was 2 minus p, which is 3, and we got y is equal to negative 1. Assuming I didn't screw up that again. 6, 2. 1, 2, 3, 4, 5, 6. 6, 2 would be right there. Focus is 6, 5. 3, 4, 5. So 6, 5 would be right there. Looks like they're a distance of what, 3 apart? Okay, and then y is equal to negative 1. Yeah, that looks right. Okay, I'm gonna pick a point over here. I'm eyeballing distance between the focus and directrix. That looks good. That looks good. So, more or less. And then by symmetry, this will look very similar. But it flipped across that line. It's kind of like, if you want to think of it, you got a line of symmetry. It passes through your focus and your vertex, like that. And I believe that was the last problem. So we're done with that section. The parabola.